I'm going to start off by pretending I have never heard of an exponential rule in my life. I would like to see if I can develop one or two of them from scratch. That's the objective of this discussion board. We want to find out why this is x to the power of 4 plus 3. And why, maybe I should write the word why, not question mark, why that is equal, and why this is equal to an x with an exponent of 4 times 3. This is the goal. The goal is this. To that end, let's look at x to the 4th times x cubed. The only thing we know is what I posted at the top of the discussion board. That tells us that x to the 4th is a product of 4 x's. This right here is x to the 4th. And it is being multiplied by x cubed. This is all we know how to do. We don't know anything else about exponents at this point, except that what it said in the top of that discussion board was that the exponent just counts up how many x's are being multiplied. Well, when I look at this, what I have written down here, the only operation that's happening is multiplication. There's no addition or anything else. So those parentheses are extraneous. They aren't really doing anything for me except grouping this together as x to the 4th and grouping this together as x cubed. So it's just certainly fine to just ditch those parentheses. And this is the same thing. Well, since we know that the exponent is counting up how many times we are multiplying that base, this would have to be x to the 7 power. But then we look back. We say, oh, we're trying to find a rule. I would like to know if there was a shortcut for me having to do this every time. And I say, well, how did I get 7 of these things to begin with? Well, I got 7 of them because there was 4 here and there was 3 here. And where did that 4 and that 3 come from? Well, they came from these exponents. And I say, oh, I get it now. What had happened was that we got 7 because there was 4 x's and then there was another 3 x's. This is how you demonstrate what to do. I didn't use any rule here. I'm just showing you what must be true based on that property, based on the property that x to some power is just x times x times x times however many x's you want, however many, not however many you want, that this is n many. Whatever n is, that's how many x's are being multiplied. And that's the only thing that we used here. That's what you want to do. Okay, so it stands to reason. It stands to reason that in this example, all we needed to do was add those exponents. So we can imagine then that if it was any 2 other numbers, that all we would need to do is add the exponents. Okay, there's our first rule. Now we would like to show how can we solve this. And I want to leverage what we already showed to be true. Well, what we know here, if I forget about all these extra symbols in here, just pretend for a moment it says this. Then this would just be star times star times star, because there's 3 of them, because of the 3 in this exponent. Okay, well that sort of tells me what I should be writing. Because what was star? Star was this, x to the 4th. So how about we say that this is x to the 4th times x to the 4th times x to the 4th. Okay, that works for me. And wouldn't you know, this is a product of 2 guys with the same exponential base, x. So I can use the previous rule. I can use the previous rule. I can say that these 2 things down here, I'll just focus on 2 at a time. These 2 guys together, based on what we just talked about, would have to be x to the 4 plus 4. That was using the previous rule. And then I still have this other x to the 4th right here. And then I rinse and repeat. Now I have these 2 guys being multiplied together. Let me add their exponents. Now it's all simplified down. And 4 plus 4 plus 4, that's 12. This is x to the 12. But I say, wait a minute. 12, where did that 12 come from? It came from the addition of these 3 4s. How many 4s were there? There were 3 of them. And isn't it true that 4 times 3 is just 4 plus 4 plus 4? It's 3 4s being added. So I can surmise then that probably what I should be doing is just saying that this is x to the power of 4 times 3. That's what it means to be times 3. If I take something times 3, I'm going to add those things that thing 3 times to itself. And now I think I've got my other rule. Because if it worked on these numbers weren't special. These numbers weren't special. I could go through here and replace all the 4s. I could go through here and replace all the 4s with m's. There's nothing special about a 4 compared to an m. They're both numbers. It's just that m is a placeholder for a number. Can be whatever number you want. Put whatever number you want in there. Here I am, replacing all the 4s with m's. And nothing has changed. Well then, what's to keep me from replacing this 3 with an n? Well, the only thing keeping you from doing that is you would have to kind of put these dots and then indicate that you have n many of these. If you have n many of them being multiplied together, then perhaps right here I could add together the first n minus 1 of them, and then the nth one is right there, so that when it was all said and done, actually you don't even need this step. We would just have how many m's have to be added together, n many of them. And if I'm taking m and adding it over and over and over again, how many times? N number of times, then you have m times n. There's our rule. I could have done the same thing for this rule. You have x times dot 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 times x. How many are there? You have m many. And you're multiplying that by x times dot 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 times x, and you have n many. So what's the grand total number of x's you have there? M plus n. This is what we want. So don't simply showcase the rules. That's not interesting. I want to know why those are the rules. And the reason why is right here. This is the reason why for the addition. This is the reason why for when you add the exponents. And then to show why for when we multiply the exponents, you leverage the first rule to show that the second one is also true.